First-person games are of course extremely common, and there's actually a surprising lack of information when it comes to creating solid first-person movement. So in this video we'll have a look at creating a character controller, the theory behind it, and how to make it perfectly fit your game. But first, this video is sponsored by Aptuti. One thing that has always been very difficult when publishing a mobile game is getting it onto the Chinese market, which is the biggest mobile game marketplace in the world. With Aptuti, this has never been easier. They offer several different publishing package solutions. With the basic plan, they take care of publication to 3 Chinese app stores and translation of the first 1,000 words for free. They monitor the application each step of the way and can help with IP certificate and Chinese publishing license application. Their Super SDK allows you to use the same build for multi-store publication, which is just extremely convenient. Get started by clicking the link in the description and use the coupon code Brackeys 2019 for a 40% discount on upgrading from their basic plan to ISPP Plus for access to more stores. Also, special thanks to Infinity PBR for his support on Patreon, and with that, let's get our move on. But before we actually start creating the controller in Unity, I think it's a good idea to have a look at some of the theory. So in general, movement in Unity can be done in 2 ways, using the character controller component or using the rigid body component. And both definitely have their advantages depending on what you want to do. Now, the main problem with creating a universal character controller that works for everyone is that what you want your character controller to do completely depends on your game. Of course, everyone wants movement, but there's also gravity, jumping, drag, in-air movement, handling slopes, handling steps, sprinting, crouching, and interacting with physics objects, just to name a few. And some of these are easier to do with the character controller approach, while others are much easier with the rigid body approach. In fact, there's also quite a few things that you don't necessarily think about, but are pretty important for the movement, such as adding a ground check to know if the player is currently standing on the ground, and adding logic to make sure that the player doesn't get stuck on walls. Now, over the years, I've tried hundreds of different ways to create character controls. So for the sake of this video, I think we should boil it down to the most simple way of getting some really nice controls that can still handle movement, gravity, ground checking, jumping, in-air movement, steps, slopes, and that doesn't get stuck on walls. And without a doubt, the simplest way to do this is using the character controller component, since much of this stuff is already built in. This way you can also easily add more things such as crouching or sprinting. The only real restriction is that the character controller doesn't interact with physics objects. Of course, there are ways to get around this for most cases, but again, that is for the future. So let's jump into Unity, and before we start with the movement, let's add a player with a camera that can look around. So the first thing that we're going to do is create an empty object. So let's go to the hierarchy and hit create and select create empty. Let's name this object first person player. And let's drag it into the center of our scene. Next up, we want to add a character controller component. So let's hit add component, search for character controller and hit enter. And if we now hit F and turn on gizmos, we can see the green outline of our character controller. Now I'm going to go ahead and set the radius of this to 0.6 to make it a tiny bit wider. And I'm going to set the height to 3.8 to make it taller as well. Of course, this isn't very visible, so let's go ahead and create some graphics for us so that we can easily see it within our scene. To do this, let's right click on our first person player, let's go 3D object, and let's create a cylinder. I'm going to set the scale of this to 1.2 by 1.8 by 1.2. I'm also going to go ahead and remove the capsule collider. The reason for this is that the character controller itself also acts as a collider. And let's also add a material to this that isn't just a boring gray. So in our project, let's create a material. Let's call it player material. And let's just make it a bright red and drag it onto our player. Awesome. So now that we have our player in place, it's time to add a camera so that we can have a look around. If you don't have a camera in your scene already, you can of course right click and simply create one. Or to make sure that you don't have multiple cameras, you can simply take the one that you already have. In my case, I have a main camera here, and drag it under our first person player. I'm going to reset the transform here, and then I'm going to move it up on the Y so that it's almost at the top, but still leave a tiny bit of space here. The reason for this is that if you go ahead and jump into a ceiling, I don't want my camera to clip through. And also we want it to stay inside of our graphics object here so that it's not visible to the camera itself. And with that, our player is set up and we're ready to start adding logic. And the first thing that we want to do is create a player look script that is of course responsible for our ability to look around. Now, looking around is actually fairly simple. Of course, everything is controlled with the mouse, and the mouse can be moved on two axes, mouse X and mouse Y. If we move our mouse on the X or from side to side, we want to rotate our entire player around the Y axis. This allows us to turn around. If we move our mouse on the Y or up and down, we don't want to rotate our entire player. We just want to rotate our camera on the X axis. This allows us to look up and down. Now it's a good idea to limit the rotation of our camera to 180 degrees so that it doesn't flip to point behind the player. This is called clamping. Alright, with that in place, we can go ahead and select our camera, and here we want to add a new component, and let's call it mouse look. Let's hit new script and create an ad, and let's double click it to open it up in Visual Studio. Now the first thing that we want to do here is go into our update function and gather some input based on our mouse movement. So we'll go ahead and create a float called mouse X and set this equal to input.getAxis, and the axis that we want to get is the mouse X axis. Now this is of course a pre-programmed axis inside of Unity that is going to change based on our mouse movement. If you want to see this for yourself, you can always go into Unity, go Edit, Project Settings, Input, and here you can see the mouse X axis. Now Unity is currently redoing the entire input system. This here should work for a long time, but if you're getting issues, definitely check out our video on the new input system. So we'll go ahead and gather that input here. We'll also do the same for the Y axis. So we'll create a mouse Y and set it equal to input.getAxis mouse Y. Of course, it would be nice if we could control the speed of our mouse. So let's go up here. Let's create a public float called mouse sensitivity. And let's just default it to 100. Then when we gather the input, we can simply multiply with our mouse sensitivity. And because we're doing this inside of the update function, we want to make sure that we rotate independent of our current frame rate. To do that, we also want to multiply with time.delta_time. Remember, time.delta_time is the amount of time that has gone by since the last time the update function was called. And so we can multiply with this value to make sure that if our frame rate is high, we're not going to be rotating quicker than if our frame rate is low. And let's just do the exact same thing for our mouse Y. Awesome. So let's start by having our mouse X, or our mouse movement from side to side, rotate the entire body of our player. Of course, in order to do this, we need a reference from our main camera to our entire first-person player object so that we can rotate it around. To do this, we'll simply create a public transform, and let's call it player body. Then inside of our update method, we can now access player body.rotate, and here we can specify an axis that we want to rotate around. So we're going to rotate around vector3.up, so our Y axis, and let's multiply that based on our mouse X. And if we save that and go into Unity and link up our player body, we can now look around using our mouse X movement. So next up, let's implement our mouse Y, which means that we want to move up and down. And this of course means that we have to rotate around the X axis. So let's go ahead and create a private variable up here. Let's make it a float and let's call it X rotation. And by default, we'll set this to 0. Then down here in our update, we can say X rotation minus equals our mouse Y. So every frame we are going to decrease our X rotation based on mouse Y. Now why are we decreasing here instead of increasing? That's simply because I've tried this before, and when I increased it, the rotation was flipped. So simply go ahead and put a minus here. And what we can then do is down here, we can apply this rotation. So we can say transform.local rotation equals quaternion. And remember, quaternions are responsible for rotation in Unity. And we want to input some Euler angles, so we'll do .Euler. And here we can simply give it an X, Y, and Z rotation. So in our case, we want to put in our X rotation for the X, 0 on the Y, and 0 on the Z. And there we go. And the reason why we're keeping track of our X rotation in this way, instead of just rotating it by calling .rotate, is so that we can go ahead and add just one more step, and that is of course clamping this rotation. So we'll set X rotation equal to math.clamp, and here we'll say that the value we want to clamp is our X rotation, and we want to clamp it between -90 degrees and 90 degrees. This way we make sure that we can never over-rotate and look behind the player.
Finally, I'm just going to add a single line of code up here in the start function, and this is just going to go ahead and hide and lock our cursor to the center of the screen, so that when looking around, our cursor won't be visible and just leave the screen and will click outside the window. That's extremely annoying. So we'll just set cursor.lockState equal to cursor_lock_mode.locked. And with that, we can save the script, head into Unity, and hit play. And as you can see, we can now also look up and down, which means that we have a working mouse look script. And if we go ahead and try and look very far upwards, as you can see, we cannot look further than the 90 degrees, and the same thing when looking down. So next up, we're ready to create some player movement. To move our player, we again want to gather some input. Remember, this is using the current input system, so this might change in the future, but for now, we can do this by getting some input on the horizontal and vertical axes. Just like with the mouse X and mouse Y, in Unity, these are pre-programmed to map to the keyboard, so that if we hold down W, vertical will be 1. If we hold down S, vertical will be -1. The same thing applies to horizontal, but with the A and D keys. And the cool thing is that these axes are also set up to automatically work with controllers. So based on this input, we can move the player to the sides along the X and forwards and backwards along the Z. We also want to make sure that we do this locally so that we are always moving relative to the direction the player is facing. So to implement this in Brackeys, let's go ahead and select our player. Let's add a new component. And this is going to be our player movement script. Let's say create an add and open it up in Visual Studio. And of course, the first thing that we want to do here again is get some input. So let's create a float called x and set it equal to input.getAxis of horizontal. Let's do the same thing with the z, set it equal to input.getAxis vertical. And now we've got some input. Now let's go ahead and take this input and turn it into a direction that we want to move. So let's create a vector3 called move, and you can simply consider this an arrow that points in the direction that we want to move. So we'll set this equal to, and here you would think that we just needed to create a vector3 and input our x, then 0, and then our set value. However, this would be global coordinates, and so we would always move in the same direction no matter what way our player is facing, and that's not what we want to do. Instead, when we are moving left and right, we want to use transform.right, which takes the direction that the player is facing and then goes to the right, and we'll multiply that with x. On top of that, we'll add transform.forward, which again takes the direction the player is facing and goes forward, and we'll multiply that with z. And so we've now created a direction that we want to move based on our x and z movement and the way the player is facing, and we can go ahead and simply move with this. Of course, in order to move, we need a reference to our character controller, because this is kind of the motor that drives our player. So to do that, we'll go up here and let's create a public character controller, and let's just call it controller. In fact, let's also get rid of our start method. We don't need it. And now down here, we can simply call controller.move, which is a function on this character controller that takes in, as you can see, a vector3 with a motion. And here we can simply put in our move vector3. And that should actually work. Of course, it would be really nice if we could control the speed of this movement. So let's go ahead and create a public float called speed and set it equal to 12 by default. Then down here where we move our player, we can simply multiply our move motion by our speed. And again, because we're doing this inside the update method, we want to make sure to multiply with time.delta_time. This way we make it frame rate independent. And that should actually be it for our basic movement. If we now go ahead and save this and go into Unity, remember to reference the character controller, and we hit play, we should be able to move around. And indeed we are. And notice how when I turn the camera, the direction that I am moving is also turning. So that means that we are correctly applying our movement based on the local coordinates of our player. Awesome. Now you will also notice that I currently cannot step up these stairs. The reason for this is that we need to change the step offset of our character controller. I'm going to increase this to something like 0.7, and that should definitely allow me to climb these stairs. You can also see that there's a slope limit here that defines how steep an angle your character controller can climb. Currently this is set to 45, which I think is just fine. So let's go ahead and hit play. And you should now see that we can go ahead and walk up these stairs. Of course, we currently have no gravity applied, so we're not going to fall again. But you'll also notice that we can walk up this slope. So now that we have that working, we can go ahead and work on the gravity. Now, applying gravity is actually pretty simple. All we need to do is try to move the player down a little bit each frame. However, one thing about gravity is that it's a force being applied over time. And because of this, the velocity or speed of the fall is going to gradually increase. So to properly simulate this, we add a velocity variable. This way we can increase our velocity based on our gravity each frame and then apply that velocity to our player. Of course, this also means that we have to reset our velocity when we are on the ground, and so we have to add a way to check if we're currently grounded. So let's start by implementing our velocity. Let's go up here to the top and let's create a vector3 that is going to store our current velocity. Now inside of our update method, let's simply go ahead and increase velocity.y, so our up and down axis, by some gravity number. And let's just add this here so that we can control that as well. Up here, let's create a public float with our gravity and let's default it to -9.81. Then down here, we can simply add that gravity onto our velocity on the y. And we'll of course go ahead and multiply this with time.delta_time as well. Then in order to add this velocity to our player, we can use controller.move once more. And here we simply want to move based on our velocity. However, as you can see from this equation here, the amount that we want to move on the y is actually going to depend on our gravity multiplied with time squared. And because this is squared, we actually need to multiply with time.delta_time once more. Why, you may ask? Well, that's just the physics of a free fall. So if we save that and go into Unity and move our player up, and let's hit play, as you can see, he's now going to appropriately fall to the ground. However, if we then go ahead and move up a slope here and drop off the edge, you can see just how fast that went. And the reason for this is that we're currently constantly building up velocity and not resetting it at any point. In fact, if we go ahead and go to debug mode in the inspector here, we can see our velocity on the y just rising and rising and rising. So to change that, we're going to go ahead and add a ground check. So I'm going to zoom in on the player here, and I'm going to right click and create an empty object. I'm going to move this to the very bottom of the player. I'm going to rename it to ground check. And basically all this object is going to do is be responsible for doing a physics check to see if our player is currently standing on anything. And it's going to do that using a method called checkSphere, where it's simply going to project an invisible sphere around this point and see what it collides with. So to do that through script, we first of all need a reference to the object that we just created. So we'll create a public transform called ground check. We'll also create a public float with the ground distance. This is going to be the radius of the sphere that we'll be using to check. And finally, we'll also create a public layer mask. And we'll call this ground mask. And that's just because we want to control what objects this sphere should check for. We don't want it to register as standing on the ground just because it collides with the player. And finally, we'll create another private variable. This is going to be a bool, and it's simply going to store if we're grounded or not. So we'll call it isGrounded. Now inside of our update function at the very top here, we can check if we're grounded. So we'll set isGrounded equal to the result of our physics check. So we'll do physics.checkSphere. And this is going to create a sphere based on the ground check.position. It's going to use the ground distance as a radius. And as the layer mask, it's going to use the ground mask. So I know this looks really scary, but it's really that simple. It's simply going to create a tiny invisible sphere here at this point with the radius specified. And if it collides with anything that is in our ground mask, well then isGrounded is going to be true. If not, isGrounded is going to be false. Then we can simply check if isGrounded and our velocity.y is less than 0. Well, then we can set velocity.y equal to, and here we could put in 0. That would make sense since we're not moving down, we're standing on the ground. However, since this might register before we are totally completely on the ground, I found that setting this to something like -2, a fairly small number but still there, just to force our player down on the ground actually works a bit better. So there we go. We are now resetting our velocity accordingly, and we can now save this, go into Unity, select our player. Here we want to drag in our ground check. And we also want to go to our ground mask, and as you can see here, we can now see all of the layers currently in our scene. As you can see, I've already gone ahead and added a layer for ground here. If you don't have this already, you can go to layers here, hit add layer, and simply type one in. You can go to ground mask and simply select the layers you want. I'm just going to press ground. That also means that I want to go ahead and take my environment, and I want to change all of the objects under here to be of layer ground. So I'm simply going to hit ground here and hit yes, change children. And now we should see that if we play and fall down here, we're going to land on the ground. And if we now walk off of this slope, we're indeed just going to fall as normal. And it works with slopes, it works with stairs, and everything is good. I definitely think that the fall is currently a bit too slow for my taste. So I'm going to go ahead and multiply our gravity with 2 just to make that a bit quicker. But that's of course completely going to depend on the game and style you're going for. Now with our ground check implemented, jumping is extremely simple. All we need to do is check if we're currently grounded and if the player is pressing the jump button. And if that's true, we can simply set our Y velocity to some number depending on how high we want to jump. In fact, we can use this neat little physics equation to calculate the amount of velocity needed to jump a certain height. We simply take the square root of our desired jump height multiplied by -2 multiplied by our gravity. I love physics. So inside of our script, before we apply our gravity, we can simply go if input.getButtonDown jump. This is another default input that automatically maps to the space key. And we're currently grounded. Well, then we can set velocity.y equal to the square root, so math.square root of our desired jump height, and here we need to go up here and create a public float with our jump height. And I'm just going to default that to 3 units. And so we can put our jump height here, multiplied by -2, multiplied by gravity. And that's all we need to do. We can now just save that, go into Unity. Let's move our first person player down so he doesn't fall every time. Let's hit play. And maximize our game view here. And as you can see, our player can now jump as well. And that means that we now have a working first-person controller that you can easily expand upon. Awesome!
That's pretty much it for this video. So from here it's up to you to expand on the character controller and add in the features that are right for your game. And if that seems too complicated, I really recommend picking up an asset like Ultimate FPS on the Unity Asset Store. It's an amazing, really solid character controller with pretty much all the features you can imagine. And of course, if you like this video, make sure to subscribe so you don't miss the next one. And for example, check out our video on shooting, which will naturally take you one step closer to a finished FPS. Also, don't forget to check out App2D. Simply click the link in the description to get started publishing your game in China and use the coupon code Brackeys 2019 for a 40% discount when upgrading your service. On that, thanks for watching and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in September, and a special thanks to Kirill Sviderski, Infinity PBR, Dennis Sullivan, Peter Schrendiman, Lost to Violence Loved Forever, Chris, Faisal Marify, Leo Lisette, Runin, Daniel Dosanik, Stig Christensen, Jacob Stanford, Naoki Wasaki, Gregory Pierce, The Mighty Zeus, Edison the Fierce, and Erasmus. You guys rock!